But note the cell addresses. The 40 is in which cell? C what? C4. So we have C4. What about that for the 50? D4. So the cell addresses is very important. Now, push the projector this way a bit. Yes. Yes. Continue pushing. Push. Yes. So that's fine. If you look at labor, we said that this is a labor constraint, not so. We then put the parameters of labor here. You see that this one is, Muda, you are disrupting the thing now. Or I should give you a different table. See, you have a 1 and what? 2. 1 and what? 2. 1 and 2. 1 and 2. 4 and 3. That's for the clay. 4 and what? 3. So here, what you have here, they are the parameters, the known values. Okay. But we don't know X1, not so. Which cell can we find X1? What's the cell address? X1, where can we find it? See what? No. Come again. X1, remember, X1 is what? Number of moles to produce. So where? Yes, it's in B10. Here, we don't know it. That's why it's blank. Number of marks is in B11, which is X2. We don't know it. That's why it is blank. The same thing, we don't know the profit. So it's 0, we don't know. But we know the equation for profit. What's the equation? This is the equation. Not so. This is simply the equation. It is 40 what? X1 plus what? 50x2. So look at it this way. Where is the 40? It's a what? C4. Plus, because that's this plus. The 50 is what? It's a what? T4. So T4, and then X2 is in what? 11. So T4 times what? 11. So that's this one. 50 times X2. So that's what it's here. So when you put your cursor here, this is a formula, it's not a normal cell. It's a formula. So when you put the cursor here, the formula will appear here. So you see that this one, C4 times E10 plus D4 times what? So you don't interfere with this cell because it's a formula. When you treat it, you have messed up the cell. So you don't touch it. This one is also a formula. This is a formula. This is a formula. This is a formula. So we have written the objective function, but we have not yet written the constraints 1 and 2. This one. So how do we write them? you see that if you come here, you have the left-hand side and the what? The right-hand side. So this is the left-hand side. That's this one. And this is the right-hand side. See 40, 120, 40 what? 120. In Excel, this is how we write it here. Less than or equal to. Less than or equal to. So this equation is what is here. This equation is what is here. So we need to find the left-hand side for this one. We said it is what? 1 times what? X1. So in this here, is 1 times what? X1 plus 2 times what? X2. That's the formula we need to write here. So the one is in this here, not so. This is the one we are talking about. Times what? X1 plus 2. This here times what? X2. So that's why this one is what? C6 times D10, which is the X1, plus T6 times what? 11. So that's what gives you this. So once again, this is a formula. The same thing is here. So this one you have to do second constraint. We said that one is 4x1. So this is the 4 times what? X1 plus what? We have 3 times what? X2. So that will then give you this one. So that is the formula for this. So we say it's less than or equal to 120. That's the right hand side. So this is the right hand side, this is the left hand side. So this is the first constraint, this is the second constraint. Now, you can either use some of the resources or all of the resources. Right now, we don't know how much we are going to use. So that's why you have 0, 0. If we run the result, the answer will be provided. So to know how much is left over, it will be what? Usage minus what? Availability. So that will be the leftover. So here you have G6. Sorry, G6, that's this one, minus what? B6. So availability, G6 minus E6 will give you this. Then this one will be what? G7 minus what? E7. So that will give you this. So because these ones are 0, 0, so this will repeat. Yeah. So this is how the interface looks like, the setup. So when you understand this, once you have a linear programming problem, you yourself, you can enter it in the spreadsheet and then follow the same thing and do the formulas. Then you can run it. So to solve this, go to data. So you see data. On your extreme right, you will see a question mark with an arrow directed to solver. See solver here. Yes. So you see solver. So once you click on the solver, the interface will show. And if you click the next one, solve, it will give you the solution. Everything. But I'll show you later how to enter the parameters into the solver so that you can get it. So when you click on solve on the solver, this interface will appear on your computer. The topmost place where you are supposed to type is saying that set your objective. That's where you put your objective function. if you go back, our objective function was in cell B12. Okay, can go back and check cell B12. So that is what is written here. $B, $12. The dollar sign is used to preserve the position of the cell. So it is still B12, but dollar sign to keep the what? The position of the. Next is to set objective to maximize, minimize, or value of one. But we want to maximize, so you click on maximize. Then we also have subject to the constraints. So this cell for the constraints, you can add them clicking on the add button here. And I'll show you how to do that towards the end of the lecture. Then, when it comes to the non-negativity constraint, you take this particular point, which tells you that any other variables and constraints should be non-negative. When it comes to the selection of the method, select simplex. Simplex L2. When you get to this interface, you just click solve. It will provide the answer for you. This is the interface that will appear. Once you continue, you get the answer here. Okay. And I'll open that and we'll do it back. To show that with this is the solution to the problem. We found what 24 what 8. 24 goes 8 what? Mass. And 1,360 profits. You see the usage where we have 00, the answers have been provided. Leftover is now what? 00. Which means that slack is equal to 0 for both constraints. So I said last week that if the slack is equal to 0 for a constraint, the constraint is what? Is it binding or not binding? It's binding. So it tells you that both constraints, that's labor and clay, are what? Binding. They are binding constraints. All right, so let's open the exhibit 3.4. Let me see, 3.1. Exhibit 3.1. All right, so once you have it opened, this is what you have. Okay, so we will still have 0, 0 here, and 0 there, where we have the formulas. They will not have the answers because we have not left solved. So you go to data, and then your solver will be at the extreme right corner. So you simply click on the solver. And this window will pop up. Yes, this is fine. Okay. So this is what you will have. So our objective function is in detail. The changing variable cells, that's the cells where we have the decision variables x1 and what? X2. X1 is in B10, X2 is in what? B11. So that's where you put the changing variable cells. Then, subject to the constraints. So the constraints are 2. This is the first constraint, which is labor. This is the second constraint, which is the clay. If I want to add constraint, I click add. Make unconstrained variables non-negative. I tick it, so it's ticked already. Select a solving method, simplest method. So it's on simplex. I don't need to describe it. When you click over there, you will see other methods that are available. We have GRG nonlinear. So this is used to solve nonlinear programming problems. Then we also have evolutionary method, but we want the simplex. So here, because the whole thing has been set up, I just need to click solve. And when I click solve, this is the window that comes. It asks me give solver solution. Then the reports that I want, answer report, sensitivity, and then limit reports. If I want any of the report, I select it. If I want all of them, I'll select it. So let me select all of them. So I want the answer report, I want the sensitivity, I want the limits. So once it's selected, then I click OK. So once I click OK, this is what I have. It's been solved. My profit of 1,360, 28 bulls, 24 bulls, 8 marks, no slack. So that's the solution I'm looking for. Now, in terms of the sensitivity report, I have this report. Now, pay attention to this report. Mostly, we do what we call sensitivity analysis. And as part of sensitivity analysis, you want to know what is the value range that the parameters of the objective function can change without affecting the optimal solution. Remember, the optimal solution is 24.8. So how much can profit per unit of gold change for 24 bulls to still be the solution? That's what we mean by the sensitivity feature. for this particular analysis. So if you check here, you have allowable increase and what? Allowable decrease. Above the 24.8, we already know them. That's the solution. These are the coefficients of the objective function. You get 51, you produce 41, you produce 1 mole, and 51, you produce 1 mole. The allowable increase of 26.666 shows that the coefficient of the objective function here, which is what, 40, can increase by 26.7, and still the right solution will be 24 moles, and then what? 8 mass. In other words, if profit increases by 26.67, it's not going to change our solution. It will still be 24.8. So that is the allowable increase. The allowable decrease is that if profit decreases by $15, it will not affect the optimal solution. The optimal solution will still be what? 24.8. So that's how we interpret the sensitivity report. Now, given this, you can calculate what we call the sensitivity range. In other words, the range of values of the objective function that will still make the solution optimal, to remain optimal. So, for instance, we said that the allowable increase is what? 26.1. 7. And the decrease is what? Meanwhile, the profit itself is what? 40, not so. So, what will be the upper boundary? What is the maximum increase that is allowed for what? For the objective function? Is the what? The 26. So you add the 26 to the 40, you get what? 6.1. So this is the upper boundary, or call it the upper bound. Now, the allowable decrease is 15, not so. So 15 minus 40 minus 15 will give you what? 5. So this is the lower bound, and this is the upper bound. In other words, so long as the objective function parameter falls between 25 and 66.7, the solution will not change. It will still be 24 moles, 8 what? Mass. The same thing applies to the solution for the mass. The allowable increase is 30, and the allowable decrease is what? 15. So with that, you can calculate the upper bound and the what? The lower bound to get the sensitivity range. Okay, so at what range will the value of the objective function parameter change without changing the optimal solution? That's what we mean by the sensitivity range. You can calculate the sensitivity range also for the constraints. It also has allowable increase and what? Allowable decrease. But added to that, in the constraints, we have what we call shadow price. What is shadow price? What is shadow price? Then you have accountants and then finance experts. shadow price or shadow value. Okay. So here, the shadow price for labor is 60, which means that unemployment of one additional unit of labor will bring $16. When you add one more unit of labor, the value of that labor will be what? $16. So that if you want to hire an extra labor, so this particular company, for an extra hour of labor, and the person says that I'm charging 18 cents, it's already off. The person cannot bring value up to 18. So you say that in my budget, you are out of my budget. The same thing with the clay, the shadow price is 6, which means that an additional pound of clay will give you a value of $6. So if you go to buy clay and they say 1 pound is 10 cents, then you know that it's off, it's too expensive. That from that 10 cedis, you cannot get up to 6 cedis value from it, and more than 6 cedis value. So that's the rule of the shadow price. Okay, so you need to take note of that. So what I'm simply drawing your attention to the fact that in most of the cases, actually, what you encounter will require that you understand the resource and how to interpret. Okay, so I can give you a results like this and ask you, what does this mean? So you have to read it and tell me what each value means. But it's not just some gymnastic exercise. But each value stands for something, and you must know the meaning. That's why I'm speaking until my throat is dry. All right. I talk about all right. So now that we know how to use solver to deal with this problem, now let's use QM for Windows. You have QM for Windows. Let's see how the solution there looks like. So open that one up. Now, once you open it up, this is the interface you want. We are doing linear programming, so look for linear programming. So I just click linear programming. I'm not actually to do any exhibit. Said open QM for Windows, not exhibit. Okay, so when you click on linear programming, this is the interface that will come. You have title, so you can type the title there. Number of constraints. How many constraints do we have? We have two main constraints, excluding the non-negativity constraint. So here 2 is selected. If it is more than that, you can click here and then you can change it. Number of decision variables, how many? There are 2, X1 and what? X2. Our objective is to what? Maximize, so you click on maximize. Then from here, just click OK. So once you click OK, this interface will appear. All you need to do is to enter the parameters where they should be. So here is maximize. X1, X2. Now, so what you need to do is, the maximize is the objective function also. So, what is the profit for X1? 40. So you type it there. The profit for X2 is what? So you type that one here. Okay, so 40 and then 50. Once as you are typing it, the equations are also written. Okay, automatically for you. Now, the first constraint is what? So constraint 1, click on it and change it to labor. So just type labor there, labor. Okay. Now, if you look at that equation, this is that particular equation. The coefficient of x1 is what? 1. This one is what? 2. So 1, what? 2. So you type it there. 1 and what? 2. One and then 2. Then come to constraint 2. That one is clear. So you can type it, clear. That one, the coefficients are what? Is it 4 and 3 or 3 and 4? 4 and 3. 4 what? 3. So you type them in and let go agree. Now, so once you switch it. Fingerprint. Yes, sir. I do fingerprint signature. Okay. Second one, the zoom to take. Zoom 1. You are using it. Okay, then let's do it. Yes. Or you charge it? Okay. Once it's charged. All right. So once we enter this one, you just need to enter the parameters. Okay, so once we enter the parameters, we are good. Okay, so you just need to click solve, the green arrow, solve. And the solution is provided. Sorry. We didn't complete the constraints. Sorry. So go back to edit data. So it will bring you back to the data. If you look at the labor constraint, the right hand side is what? 40, not so. And the clay one is 120. Okay, right. So we can now solve. So once you now solve, this is what you have. So the same solution, 1,316. Then we have 24. X1 is 24, X2 is what? Now, look at something here. Here we have dual. It's the same as the shadow price. The dual value is the same as the shadow price. But this one also gives you the graph. So you can click on graph. Okay. So it will give you what the graph we plotted last week manually. So you now have the computer generate that one. And this is the solution. This line is a objective function line. We also call it the isoprofit line. Isoprofit because at any point on the line, the profit is the same. 1,360. So if you come to solutions, you can see the solution list. So let me click on ranging. Click on ranging. I see this output. This output gives you the lower bound and the upper bound values for the sensitivity ranges. So, hello. If you take labor, we found the upper bound to be what? 6.67. And the lower bound to be 25. So this one gives you the exact boundaries. Unlike the solver, which gives you allowable increase and what? Allowable decrease. That's just the difference. This one will give you the boundary values. So the range for X1 is 25 up to what? 66.67. And for X2, it is what? 30 to 80. And then for labor, it is what? Also 30 to what? 80. And then for pay, it is what? 60 to 160. And once again, shadow price, and then what? Whether there is surplus or slack or not. And when we see 0, 0 here, we say that the two constraints are binding. They are binding. Go to solutions. You see the list of solutions. So you select ranging and you see the results. So any results you want, there are about 6 results. But we just selected the ones that suit us. And these are all results. Right. Okay. again. Now, so I've taught you how to interpret the sensitivity ranges. But more than that, if you have a two decision variable problem, you should be able to calculate it mathematically. Okay, so that's really what we are going to go through. Now, the key term is sensitivity range. So we said that it is simply the range of values over which the current optimal solution point will remain optimal. So the range of values of the objective function coefficient for which the current optimal solution point will remain optimal. In other words, we will not change our decision for x1 and x2. So that range of values is what we are looking at. So yeah, we're looking for range of values for 40 and then what? 50. Range of values for 40 and 50. These are the coefficients we are talking about. So, because we don't know the range of values, we represent this by C1 and this by C2. But we want to find C1. The range for this one is called C1. The range for this one is what? C2. Okay. So we can rewrite Z as such. Okay. Or we can say this is equal to simply C1, so this is lowercase S1 plus what? C2 what? This is what we also call the isopropyl line. Okay. So this C is simply a constant. So in place of this, we can then say that constant is equal to C1 X1 plus what? C2 y. Now, what we want to do is to find the slope of the isopropyl line. So this the objective function. We want to find the slope of it. To find the slope of this line, we simply make x to the subject. So this particular equation, we make x to the subject. Okay. So if you are making x to the subject, you have what? X2 will be equal to what? So let's be systematic. C2 X2 will be equal to what? Will be C minus what? C1 what? X. We now divide 2 by C2, not so. So C2, C2, C1, 2. So this cancels that. So we now have what? This will imply that X2 will be equal to what? B over what? B2 minus what? Minus C1 C2 times what? X1. So if you have an equation like this, remember Z is a constant. This is a constant. So this is equivalent to saying that X2 is equal to A plus B X X1. Where this one is this B, which is the slope parameter. is this one, C1 over C2. So in other words, for this particular equation, the slope is simply negative C1 over what? C2. So the slope of the isopropyl line is negative what? C1 over 1. So this is the slope we are looking for. And this is the rule. When you are dealing with a problem where there are two constraints, and the two constraints are binding, the sensitivity range of the parameter for the objective function must be such that the slope of the objective function will be in between the slope of the two constraints. Remember, we have two constraints. We have slope for what? X1. So slope for what? X1, and slope for what? For X2. X2. We are saying that this one must be in between these two values. That's the condition for deriving the sensitivity range for the objective. Now, the slope of the objective function must be in between the slope of the two constraints, provided that the two constraints are what? Binding. Saying that in this case, the two constraints are what? Are binding. Yeah. So it means that how to solve the problem is that we find the slope of what? X1 and the slope of what? X2. And just put this one in the middle. That's what. So that's what the condition is. We find slope for X1 and slope for what? X2. We'll put this one in the middle. That's it. Okay.
That is why they do not come in
And I'm suffering like that. You think I'll suffer like this? And am I going to suffer? No one. Okay. So for the first constraint, we can find the slope. It's the same manner that we found the slope for the objective function. That's the same process we follow. So the first constraint we can call is C1. Yeah, this one is capital. C1, constraint 1, which is what? The labor constraint, not so. So, and we said that the labor constraint is what? X1 plus what? X2. So here we use the equality. Equals what? So here make X2 the subject again. The same. Okay. So making X2 the subject, it will mean we'll have what? X2 is equal to what? Minus what? X1. So it means that X2 will be equal to what? 40 over what? Minus what? X1 over what? So from here, we have what? X2 will be equal to what? 20 minus what? 1 over what? 2 what? X1 is the same as X1 over 2. Okay, it's the same thing. So what is the slope for the labor constraint? Minus what? Minus half, not 2. So the slope for X2 is equal to what? Negative what? So let's look for C2. That's the clear constraint. Okay. We said that one, the equation is what? 4x1 plus 3y x
X two.
Close to 120.
120. So similarly, we make x to the subject. So making x to the subject, we'll have a 3y
X two.
x2
Minus 120. 120.
is equal to what?
120.
Minus
Minus
4y
Six.
xy 1. So x2 will be equal to what? 120 over what? Minus what? 4x1 over what? So what is the slope? So slope is what? Minus 4 over what? 3. So we have found the slope. So it means that negative C1 over C2 is in between what? Negative 4.4 over what? 3 and then what? Negative half. That's what it means. Because we lay down the condition from the beginning. So it means that negative 3 over negative 4 over 3 and negative half, which one is greater than the other? The half is greater. So it means that we can write it as what? Negative what? 4 over 3. Less than or equal to what? Remember, we said that this will be in the middle. Don't forget. The slope of the what? Objective functions will be in the middle. So less than or equal to what? Negative 1 over what? C2. Which is also less than or equal to what? Negative half. Okay. So with this, we can find the boundaries. So for instance, suppose C2. So if C2, from our example, C2 is equal to what? If you go back to the objective function, C2 is what? It's 50. Now we have 40, 50. You get 50 profit when you what? You produce a map, and 40 when you produce what? A book. So if we say that we are using the 50, so C2 is equal to 50. Then we can, in place of C2, we can put 50 there. So we will now have what? But before then, because I know from experience, some people, once they see negative, their blood pressure is. So in order to solve that problem, then multiply this by negative half. This entire equation by negative half. So that it will now be, once we multiply by negative half, it will now be what? Half. Because this one will now be greater than it. Is now less than or equal to what? C1 over what? C2 less than or equal to what? 4 over 3. But we said that C2 is what? 50. So let's replace this with 50. Okay, so if we want to solve it, it means that we have to multiply here by what? 50. Here by what? 50. Here by what? 50. Not so. So this one will be what? 25. 50 times half is what? 25.
C1.
We now have what? Less than or equal to what?
C1.
C1. Less than or equal to what? So this times this is what? 4 times 50 is 200 divided by 3 is what? 66.1. Is that not what we found as the upper bound?
Yes.
So this is the upper value, and this is the lower bound. This is the lower bound. So this is the sensitivity range for S1 for the objective function. We can use a similar thing to find that for S2. And that one we now say that if C1 is equal to what? What? Okay. So we say that so we now have less than or equal to what? 40 over what? Over 6. Less than or equal to what? 4 over what? Right. So what you now need to do is to make sure that the multiply across by what? So multiply this move here, this move there, this move one. Okay, so this one will be what? Half of what? C2. Half of C2. Less than or equal to what? 40. Okay. Then this one will be what? Or equal to what? So this is how you solve it. You divide it into the left hand side and the what? The right hand side. So this is the left hand side. So solve this alone. This is the right hand side. Solve this alone. The left hand side is what? Half. This two is equal to what? 40. It means that on the left, on this side, C2 is what? It's equal to what? You multiply by what? 2, not so. By 2 by what? 2. So it will be what? 40 times 2 is what? 80. 80. So let's move to this other side. We have what? 40 is equal to what?
4 over 3.
4 over 3 what? 50. So first we have to multiply by what? So how you actually do it is to multiply by 3 and divide by what? By 4. If you want it to be short, you just because this is more or less like what? 40 divided by what? 4 over what? 3. Which is the same as what? 40 times what? 3 divided by what? 4. Okay, so the simplest way to deal with that you are just basically doing what? Like 3 over 4 and what? Multiplying there also by what? 3 over what? 4. So this cancels that, this cancels that, and then you now have what? 30 times what? 3 times what? 40. 120 divided by 4. What? So B 2 is equal to 1. 10. So we found 1 to be what? 80 and then what? 30. So it means that for C2 is between what? So 30 less than or equal to what? C2 less than or equal to what? 80. Oh, where are you confused? First,
We're going to say this one.
yeah, you can do it. Then. Yes, let me get where you are done. One is equal to. That's
Solving the right answer. That's 20.
solving the right answer.
Yes.
Okay. So we are saying that we have 40. Now you use the equality sign. It's equal to what? 4 over what? Times what? If you want to be gradual, first what you do is multiply across by what? 3. By 3. So times 3 times what? 3. So this will what? Cancel this. So you have 120. It's equal to what? 4C1. Then you divide through by 4. Okay, so that this will now be equal to what? 10. So that's how we got there. So I'm going to limit you to the objective function, how to do the calculation. I'll not go to the constraints. Because that one has its own issue. I think I should spare you that one for you. When you grow. Can hold it. Actually, so the details are in the slides. So if you go through you and let's follow. All right, there. We have about 20 minutes, right? Now, can you go ask some guys? Now, you will see that all along, we have been dealing with problems where we have mainly 2 constraints. Well, if, for instance, we have 3 constraints, I mean, which is this one? Yes. The same problem we have been dealing with, but we have added a packaging constraint. which is in hours per unit. And these are the known parameters. So that the equation for that is written here. Okay. So that one, the formula system will be the same as we deal with the rest. So if you open exhibit 3.15, we can do just some demonstration there. Now, so this is the Excel sheet for that. Properly set up. So go to your data and click on your solver. This interface will now shift it this way. Yes. This is the interface that comes. If you continue and just click solve, it will be solved. But I want to illustrate to you how to enter them here. Because if you have to construct your own, you have to enter them here. So that's what we want to do. In order to do that, I need to reset all. So once I reset all, everything here will vanish. These ones, the formulas here, they will all disappear. Okay, if you are not sure of yourself, don't try it. Okay. But if you are sure,
Yes, reset.
you can reset all. Okay, so we click reset all. So it's asking me whether I really want to do that. Say yes, I want to do that. So you see that all the formulas here and there, they are gone. So I can even take out this one. So that one too, I've deleted it. So in case you have closed your interface, when you click on the solver, this is what will come. There will be nothing in there. But once you have the formulas here, the solution becomes easy for you. Remember, I said here, set objective. That's where your objective function will be. So you see that the cursor is live there. So over there, I just come to my Excel and click on this cell, which is B113. Here. So once I click on it, it will pick it here. So I'll go to my Excel and click on B13. So you see that it gives me the sheet number and says sheet 1. If you look at here, this one is sheet 1, sheet 2, sheet 3, sheet 4, sheet 5, sheet 6, 7, and so on and so forth. But what we are working on is from what? Sheet 1. And the cell is B13. As I indicated, it uses the dollar sign to keep the position. So once I do that, then I come and click on maximize. Then the next is by changing variable cells. Over here, I have to pick the cells for X1 and X2. That is what? D10 and what? I think now, yeah, D11 and then what? D12. So I have to select these two in there. Okay, so I'll do the selection. But I have to click that place first. See that the cursor is live. Okay. So I can select them. So it's selected. So you see that I now have what? P11 column B12. So it means that it's picking from, so if you look here, you see that it's highlighted. So the two have been selected together. So I'm done with that one. The next is subject to constraint. So I click on the constraint box, this one. Now over here, I have to add the constraints one by one. Remember, we have three main constraints. So if I want to add constraint, I click on add. So once I click on add, this will appear. So the left-hand side will be written here, less than or equal to. If it is greater than or equal to, I can click here and select the appropriate thing. So let me click that arrow there. You see that it will give me options. See the options. So I can select the appropriate option. But it is where I want it to be. So we want to enter constraint one. Constraint one is what? This cell for the left-hand side, and then what? This cell for the right-hand side. So I need to select here, and then what? The right-hand side, I select here. So over here, I select this. And then over here, I select this cell. So I have to click in the cell reference. So I click on this. Then I come to the right-hand side. I click on where the 40 is. So that is the first constraint. Then I click add, not OK. If I click OK, it feels that I'm done. Okay, but this one I'll click add. Then it will give me a new interface. So I add the second constraint, which is in what? E7. And then what? G7. So I enter them as well. Then I say add because we have a third constraint. So that one is also in what? E8. So I click E8 and then what? G8. So that is all the constraints. So right now I click OK. When we click OK, when we can, you see the constraints there. They are now here. This is the first one, second, third. Make unconstrained variable non-negative. I take it. But look at here. Select a solving method. It is on TRG nonlinear. Is that the method we are using? Which method are we using? Simplex. So I click here and select simplex. Once I select simplex, I'm ready to go. So I now click solve. Now, when I click solve, once again, it asks whether I want all these reports. So I select which ones I want. Okay, so if you are like me, you want all the reports. So you click them, select them, okay, and OK. You see answer report 1. Once again, shift this. Yes, shift. See here, answer reports, sensitivity report, limits report, and this is the cell where we started. Sheet 1. That's the sheet we started, sheet 1. So from here, this is the answer report. You see that because we have now added a third constraint, the solution has changed. Now we have to produce 20 volts, 10 watt max. And here again, now the clay constraint is not binding because there's a surplus. Can you see here? There's a surplus of 10. Labor and packaging constraints are what? Binding. So if we click the sensitivity report, it will show us the allowable increase and the allowable decrease that we discussed. So we have that. We have the shadow prices and so on and so forth. So where you have the E in the answer and you come across it a lot, see, and it's positive, we approximate this to infinity. Because the figure is too large, that's why it's not entering in this cell. So we approximate it to infinity. Okay. So that's how you interpret those things. The shadow price for clay is what? It's 0. You see that is 0. That is because we have a surplus. You have surplus clay. Why are you buying more clay? So the answer makes sense. Any question? Okay, so to keep you busy during the holidays, so that while you chew the chicken, then you know that there's life after Christmas. There's life after Christmas.
This one there was you wear around a little bit, so the around that tree needs to be.
You can do both. They are not mutually exclusive. Okay, so you see problem number 2. That's last week's slide. So this one is last week's slide. Okay, so you are required to solve this problem. Even though there are highlights of the solution here, but solve it yourself. Mathematically, graphically, and what? Using and using the spreadsheet.
Yep.
So when you solve them, find out which of the constraints are binding, which are not binding. What are the slacks, if any? Then you also calculate the sensitivity ranges. Yes. This one is individual, not group. Okay? Because the exam will not be written in group. Okay? It will be individual, everyone for themselves. Yes, please. You say what?
No,
I didn't say that. I think you were not paying attention. I said that I will not worry you with the sensitivity range for the constraints. Underline constraints, not the objective function. Okay, so I choose my words carefully. All right, so Merry Christmas and Happy New Year in advance.
Chad, you said you wanted to chat.
Solve the problem That's also mathematically, graphically, and you will say computer.
Yes, yes.